Okay, so for the second part of the problem, we have the same situation. We have the spinner, but the variable now has been defined as spinning it twice and adding up the results. So spin it once and get a 1, spin it second time, get a 2. The result would be 3. So that's our variable. So I got to keep that in mind as I now try to answer the question. The problem is still find the mean, find the variance, and find the standard deviation. So what I've started with, same way that I started the previous part of the problem, is the formula for mean. And again, I'm trying to motivate myself in terms of what I need. What I need are all the different values the variable can take on. So in this time, I'll even give you the formula from the book. I just do plus dot 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 plus x sub m. I don't know necessarily how many values of the variable they're going to be until I get a better feel for the situation. So that's why I'm going to come back over here and do the same work that we did with the first part of the problem, is start with a frequency distribution and a probability distribution. So the frequency distribution, x, and then the frequency for each of those x's. And even for me to start filling this out, I need to know what values x can be. So I already said, like, okay, you spin it, you get a 1, you spin it, you get a 3, the sum is 4, but I want to make sure I cover all those different possibilities. So I'm going to start even further back and do a sample space. And the sample space, remember, is the set of all possible outcomes for this experiment. The experiment is spinning the spinner twice. So what I'd like to do is try to list those different possibilities. Having that list will help me see exactly what the different possibilities are for the variable x, but it's also going to help me count the frequencies and the probability. So the sample space, spin it twice and see what you get. You could get 1, 1. And for my work here, make sure you're not seeing that as an 11. I'm trying to keep track of 2 different spins. Fortunately, the spinner only has 1, 2, 3, so the first digit, if you will, is the first outcome, a 1. And that second digit is the second spin, also a 1. And then I could get a 1 on the first spin, but a 2 on the second spin. 1, 3. So that's my thinking through coming up with a sample space, is what could I get on the first spin, a 1, second spin, a 1, or a 2, or a 3. So let me go down. The first spin, I could get a 2. The second spin, a 1. First spin, a 2. Second spin, a 2. 2, and then a 3. Just listing all different possible outcomes with commas in between. And then finally, a 3 on the first spin, and then a 1, a 3, and then a 2, a 3, and then a 3. Okay. So this helps me kind of organize my thoughts in terms of even what this variable x could be, because the experiment described to us in part B of this problem has the variable being the sum of those results of the spin. So this would be 2. I'm going to do some mental arithmetic. That's a 2, that's a 3, that's a 4, 3, 4, 5, 4, 5, 6. So I see that the possible outcomes now for x, the possible values that x could be, go from 2, which was my 1 plus 1, all the way down through 6, which is my 3 plus 3. So 2, 3, 4, 5, 6. And then in the second column of our frequency distribution, we're trying to count how many times that value for x could occur. So for the value of 2, I'm looking at how many of these different outcomes add up, the digits would add up to 2. And that's going to be the only one right there. Oh, 1. I think what I'll do for my scratch work here is even cross them out as I account for them, so I don't do any double counting and hopefully don't miss anything either. The next variable value is 3, so I'm looking for these pairs of digits that would add up to 3. So let's see, adding up to 3, that's 1, 2, and that looks like it. So I would have a frequency of 2. Frequency, a value of 4, I got to find the frequency. I'm looking for these pairs of digits that would add up to 4. So let's see, that's 1, that's 2, that looks like 3. Okay, and then my next value of x would be 5. frequency of that is I'm looking at my diminishing sample space here and trying to find pairs of digits that add up to 5. Hopefully you can see that's here. Let me change things here because I'm getting a lot of tick marks. There and there would add up to the 5. There are 2 possibilities. And then finally, just that one possibility to add up to a 6, so my frequency is 1. Takes us back a little bit, but we have to remember how to fill out these frequency distributions. So we have the different values the variable can be, and then the frequency for each of those, which comes down to how many different times does that occur, that value of the variable occur in the sample space. Okay. All right, now to get our bearings, what we're doing is trying to find this mean. And so I think I have a pretty good handle on the x subscripts now. I'm going to have 2, 3, 4, 5, 6. But for the next part of the formula, I need these probabilities. So now I'm going to need the probability distribution, like we did in part A. Is our probability distribution, just an organizational scheme really, is listing the different values that x can be. That's our 2, 3, 4, 5, 6. And then the real beef of it, though, is the corresponding probabilities for each, which we refer back to our frequency distribution. When I want to find the probability of x being 2, that frequency of 1 is my numerator, and the denominator comes from the total here. So it's maybe worth the time to do this summation here. 1 plus 2 plus 3 plus 2 plus 1. That's 9. So my probability for 2 is the 1 in the numerator and the 9 in the denominator. And I do this for each of these now then. The x value of 3 gives me 2/9. 3/9. 2/9. 1/9. Okay, really almost preliminary work, because now I've got my x's and my p of x's to fill in this formula. So let's give that a go. Following the formula, I just need each value of x and multiply by the corresponding probability. 3 times 2/9. 4 times 3/9. 5 times 2/9. 6 times 1/9. Okay, so we have our formula. Hopefully put all the right pieces of the puzzle in the right place, and then it becomes arithmetic. So hopefully we feel pretty good by that point. 2/9. 6/9. 12/9. Adding the fractions with a common denominator, we'll just add up the numerators. So 2 plus 6 is 8. 12, that gets me to 20. 30, 36 over 9. Reduce it, not too bad to do in our heads. And we'll get a mean of 4. So that's our first answer. The mean of this variable is 4. Second part of the problem was to find the variance. Our variance, I'm again going to start with the formula. It's always a good place to start to make sure you know what you need for the calculation, and then just put the right players in the game in the right place. So our formula here and of course it's the same formula as variance, so I'm going to do that same expression for each of the values of x. Let me just do dot 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 for the formula, the ellipsis. We're going to get down to our x sub m minus mu. So now I just need to plug in each of the specifics here. X sub 1 is our first value of 2. Subtract the mean, which was the 4 that we needed, calculated, squared times the probability of x sub 1, so that's our 1/9. I'm just going right down the different possibilities. The value of x, subtract the mean, squared, times that probability that corresponds to that value of x. Value of x, 4, minus the mean of 4 squared, times that probability. value of 5 minus the mean squared times that probability. Value of x, subtract the mean squared times that probability, 1/9. Whew. Okay, a little bit of work, but hopefully if you get the formula right, you know what to plug in where based on the formula. And now it's arithmetic. 2 take away 4, -2, but squared is 4. 3 take away 4, -1, but squared is +1. 4 take away 4 is 0. And then 6 take away 4, 2, but squared. Getting smaller. Now just do some multiplication. Now do some addition, just some fractions, each with the same denominator of 9, so I'll just add up across other than the 0. 4 plus 2 is 6. 12/9. That's our variance. For variance, if we want to have the 2 decimal places, I mean, we can have 12/9, but if we want as a decimal, just do 12 divided by 9, and we would get approximately 1.33. That'll be our variance. And then finally, we were asked for the standard deviation. Consistent theme here is I would always try to start with the formula, and the formula for standard deviation, just the square root of the variance. We have our value for the variance of 1.33. Get the calculator out, because now we need the square root of 1.33. Approximately 1.15 for our standard deviation. Okay, so for part B, we have our mean of 4. We have our variance, approximately 1.33. We have our standard deviation, approximately 1.15. Okay, so part B of this problem, spinner with markings for 1, 2, 3. We spin it twice though and just add up. So we had to think through our sample space, just even to determine what the values of x could be, the variable. So you could get a 2, 3, 4, 5, or 6 as the sum of the 2 outputs of the spin. And we found frequencies for each, really just to serve our purpose for finding the probability of each. We had the probabilities of each and the corresponding value of x for both the formulas of mean and the formula for variance. Run through your formulas for each, make sure it makes sense what goes where in the formula, and then do the arithmetic for each, and we get these 3 answers for this variable. Okay, a little bit of work, but hopefully that helped. Okay, thanks.